Welcome. Let's try to summarize the 10 most important ancient mathematical roots. So I organized this by dividing up things into 10. So let's start with the African roots. Sumerian, also Babylonian, then Egyptian, then I come to Chinese, Greek, Indian, then Mayan, Inca, Empire, Roman, and then the Hindu-Arabic. And I focus on the numerals, how mathematicians in different cultures have introduced numerals. So let me just start with the African. This was the oldest really approach to mathematics, first appearance of mathematics with tally sticks. So no numerals yet, but it's very old. So this is 44,000 or 22,000, so the 44,000 BC. And Ishango. So this is, there are no numerals here. So these were just marks on sticks like this. This would be a number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no number yet associated to this. And then the Sumerian or Babylonian mathematics, that's already more interesting. So we have here the cuneiforms. And it has appeared, I think, about 4,000 years, 3,200 years BC. Then became the Babylonian mathematics, and so this is the Phoenician alphabet, and which also became then the Hebrew alphabet. But this is a sexagesimal system, so there is no kind of place value yet. Here we have a base 60, and there are essentially two marks here which are important. One of them is this mark here, which is 1. And then there is this mark here, which is 10. There was no 0 yet. The Egyptians have the hieroglyphs. And that's about the same time. So also about 3,200 BC. So it's not a place value system yet, but it's based 10 based because there are these symbols which represent numbers. So there is 1, then there is 10, then there is 100, which is the monkey tail, and then there is, so this is 1, this is 10, this is 100, and then came the lotus flower, which is something like that. So this is 1000, and then came the finger, which is 10,000, and then there came a frog, or maybe something like that, a very young frog, and then finally the priest. I don't know, I cannot draw that well, but something like that, the kneeling priest. So this is 10,000, and then this is 1 million. So with this, numbers were represented. Then the Chinese mathematicians, this is the ancient Chinese, ancient Chinese. Of course, this evolved then into more complicated figures, but this is about 2000 BC. And it's a simple system. The system were like that. So it's kind of like the tally thing, but then 2, 3, 4, and then 5. So for 5, there was still like that. I think it was still kind of like that. And then 6. Let me just see whether 5 was actually. So this is definitely 6. This is 7. Maybe 5 was actually also kind of just a horizontal bar, and then 8, 9, and then so it's kind of a nice geometric representations of the numbers, which make a lot of sense. And then there's the Greek roots. It's very complicated with the Greek thing. So let me just take this. Again, language. They are called let me just call them Ionic numerals. So the Greeks were influenced by the Babylonians and also by the Egyptians. So that's kind of why these things there's the hexadecimal system comes in also in the angles, and then there is the decimal system. So it kind of is a mix. But let me just call that the Ionic numerals. This is kind of one of the earliest one, and so this is 1 is just like that, then 10 is like that, 100 is like that, just a circle, 1000 is and 10,000 is this. So this is obviously base 10, maybe base 5 or base 10 here. This is also base 10, but they also were influenced by the base 60, by the hexadecimal system here. And then we have the Indian system. So let me just pick here the Brahmanian numerals. And so let me just try that. So it starts very similar then with the Chinese. And then 4 was this. So it's already rudimentary, the 4 which we have, right? And so this is 4. And then 5, also a rudimentary 5, 6, 7, 8. No, this is 6, yeah, this is 7, this is 8, and then this is 9. I think so. 1, 2, 3, 4, 5, 6. 7 looks actually like the 7 a little bit, and so what is remarkable here? Already the appearance of negative numbers and 0, but it's still base 10. The Mayan system is interesting because it is base 20, and so this is the Mayan numerals. And so here with the time, I should also put the time for the Indian. So this is 400 to 1200. 400 is 1280. And with the Greek thing, that's maybe 2000 to 5 minus 2000, 2500 BC. So the Mayan numerals, they came later. So this is 250 until 900 BC. But they're also remarkable that there is a 0 here. So there is a 0. I think it looks like that. Somehow this is a 0. And then so then there are numbers, right? 1, 2, 3, 4, and then 5, and then so it's very similar than the Chinese mathematics, the early ancient Chinese mathematics. But there's also a 0 here. There's also a 0 here. The Inca mathematics is very special because it's not really a usual writing, it's a writing with knots. And so these are the quipus. And the time is 1100 to 1500 AD. So so this is a base 10 also. And so see, these are talking knots. Knots. So there are different type of knots. So there is so made of wool or cotton, and so there are different type of knots which are put here. Then there's also figure 8 knot, which is usually at the end. So it's a very sophisticated system. It's a graph-based writing system. Then we have the Roman mathematics, the Roman numerals, which we still use. And so maybe I'll just put the date here, maybe 100 BC. So when this was the first time seen. And so there were also what is remarkable here. So they were also kind of dealing with symbols for fractions. The Egyptians also were working with fractions with 1 over Egyptians fractions 1 over integer. And then we have the Indo-Arabic numerals, which are actually still used. This is the decimal number system, which we know. So it's base 10 here. This is also base 10, and but they are all kind of symbols here, similarly than with the Egyptians. So there are symbols for 1000, right? There are symbols for 100, etc. So they are. So this is the system we know, kind of. The system we know, and also 0 has merged in. So this is kind of an overview over all these 10 roots, and maybe I just put a little bit a color on it, so that this is more. Or let me just also say what kind of materials have been used. So here, this was based on bones. Fibulas. That was a typical way to carve things in. Here, this is clay. These are the clay tablets. Here we have papyrus. Already version of paper. Also here, some kind of paper based. For Greek, there's a lot of things on stones. Or also, so it's a mixture also papyrus. Then here, so it's birch. So in the Mayan case, we have mostly stone things. So this in stone. So these are based on wool or cotton. Also here, most of the things which survived is probably on stones. And then here we have really, then today mostly paper or electronic. It has merged into mostly electronic communication now. So this is these are it's quite complicated, and this is of course just a simplification. So there are many books like this one of Katz, the mathematics of Egypt, Mesopotamia, China, India, and Islam. So this covers a couple of these initial approaches to mathematics. And I want to maybe just color this a little bit so that we have a picture. And then maybe I make the times red. So this is amazing. This is so much. So I have here a ruler which is 2000 years. This ruler is from 0 to 2000. And so this is 10 times that. That's way off in the this side. So 20 meters off where we have these first roots here. So 3200 BC, that would be just maybe at the window here. Also this 2000 BC, maybe here, if that's the, then we have 1000, this is 1000 to 5000. So this is now 400 to 1200. So that's about here on the ruler. Also here, this is later, this is already here. Roman numerals were here, probably earlier, but that's when they really started. And then we have the modern thing, which maybe, you know, then there was a merge thing, maybe maybe in 1200 or so. I don't know if you want to put the date here. Definitely a merge between the so for the number systems, let me just actually make this. So we have no place value system. So there's already a place value system. There is also a zero kind of just nothing. Writing nothing means zero. So but this is 10 kind of 10 20. That's 10 fingers and 10 toes. And then we have also 10 here. So 10 is very natural because we have 10 fingers. 60 is very natural because it's convenient. We can divide a lot of things. So this is also still used today. You have 360-degree angles. Cool. So let me just make a photo of this.